Factorising. Factorising is the opposite of expanding, as we know, and it's a good idea to go back a bit and remember what factorising really sort of comes from. If I have a number, like the number 12, if I was to factorise this number, I could factorise it into 3 and 4, because 3 times 4 is 12. So in the same way, I can say that if I have a number, and I'll call that number xy, its factors are x and y. Moving on from this, if I have a number, for example, like x squared y plus x, I can split this up into its factors. So I can say, well, I know there's an x in both of these terms, so x is a factor. I then work out what goes and times this by x to make this whole term. So that's going to be xy plus 1. And these are the two factors. So factorising is just breaking it up into its individual products. And you've been doing this for quite a while. For example, if we have 4x, let's say 4x squared plus 8. To factorise this, it's going to go into a single bracket. And all I do is I say, well, what is shared by both of these terms? Well, in this case, a 4 is shared in both terms, so I'll put a 4 outside. And there's also 1x, x to the power of 1 in both terms, so 4x outside. What do I times 4x by to get 4x squared? Well, I times it by another x. And what do I times 4x by to get 8x? Well, I times it by 2. And we can look at some more complex examples of single brackets. And here's one to have a look at. It's 6a squared b plus 12ab plus 6a squared b squared. Okay. Now, looking at it, you might think, well, it looks a bit like a quadratic, but we can factorise it into a single bracket if we look at the numbers and we look at the a and b powers. So what number goes into all of it? Well, a 6 goes into all of those coefficients, so put a 6 outside. We have an a in each one, and we have at least b to the power of 1 in each term. So put 6ab outside. What do I times 6ab by to get this term? Well, I times it by a. What do I times 6ab by to get 12ab? 2. And finally, what do I times 6ab by to get 6a squared b squared? Well, that is just a b. Okay, so we can do single bracket factorisation, and hopefully that isn't going to cause too many problems. We will also have factorised quadratics. Now, when we factorise quadratics, the reason we do it is because I'll have a parabola, something like this, and when I factorise it and set it equal to 0, I find these points here, which are really, really important. By factorising, you take a step towards finding the roots. Okay, so factorising is a really, really important skill when you want to solve an equation. So let's just think generally about quadratics. If we see where they come from, hopefully we can realise how we can work backwards. So if I start with x plus a as one binomial times by x plus b, and we expand this using whatever method we want, whether it's box or grouping, we end up with x squared a plus b times x plus at the end ab. Now, just to show that this is what you get, I will just do it very quickly. X squared ax bx ab, and all I've done here with the ax plus bx is factorised. I've factorised ab and I've factorised an x out. Okay, so as you can see, I've used this skill that we're learning in order to do the skill that we're learning. Anyway, we end up with a plus b here, and a times b here. Now, in lower school, you may have learnt the sort of, pattern of saying, right, I want to find two numbers which add together to make this term and times together to make this term. But you can see here, algebraically, this is exactly why it works. These two middle terms add together, a plus b, and the last two terms times together. So what we need to do is find two numbers which work. So for example, if I give you the quadratic x squared plus 3x plus 2, I know that the 2 is ab and the 3 is a plus b. So I need two numbers which times together. So in this case, a plus b equals 3, ab equals 2. Now, you don't really need to go through and work this out sort of simultaneously. You can just realise and sort of work out what it's going to be. So we can see that a plus b, one of them must be 2, one must be 1. Sorry, yeah, one must be 2, one must be 1, in order for them to times together to make 2. So we can work out just from sort of inspection and looking at it that we're going to have x plus 2 and x plus 1 as my factors. Okay, this is all very happy when we have no coefficient of x squared. Let's look at a few more examples of this type of quadratic so we can get more used to the patterns involved. So, for example, I'm going to give you 4 different quadratics, which all look a bit similar. So we have x plus 5x plus 6, x minus 5x plus 6. I have x minus 5x minus 6, and I have x squared plus 5x minus 6. Okay, so these all look very, very similar, but what I want us to think about is these signs and what they do to our factorised outcome. So again, remember, we want two numbers which add to make 5 and times together to make 6. So we're going to go through all of these, and I'm going to miss out a few steps of working, but hopefully, you'll be okay at this and you'll be good enough to do this. So two numbers which add together to make 5 times to make 6 must be positive 2 and positive 3. So our factors are x plus 2, x plus 3. Okay, next one. Notice how this is plus plus, and this gives me plus plus. The next one, two numbers that add together to make minus 5, but times together to make 6. Okay, well, in this case, because the product is positive, they both must be negative, because this is negative, so there must be at least one negative, there must be 2. So in this case, we're going to have x minus 2, x minus 3. So plus minus gives us minus minus in my brackets. Next one, two numbers add together to make minus 5, times together to make minus 6. Okay, well, let's have a think. The factors of minus 6, minus 2 and 3 can't be this one. It's going to have to be 1 and 6. Now 1's going to have to be negative, that's going to have to be this one. Now, if at any point, especially with negatives, you get a little bit hung up, what I like to do is draw myself a little box, put in the minus 6, put in my x squared, and think to myself, okay, well, I know that it's going to have to be 1 and 6, so let's just put 1 and 6 in. I want it to be minus 5, so this one, it must be minus 6x, because minus 6x plus x is minus 5. So you can sort of put it in a box as well, just to inspect it. We call this inspection, just to be sure of your answer. So my answer, x minus 6, x plus 1. In this case, minus minus gives me minus plus, or I could swap it around, or plus minus. The last one, add to make positive 5, times to make negative 6. Well, it's sort of like the last one, just the other way around. We know we've got -6. We've got 6 and 1 as our factors, but the negative one in this case must be the 1 because it's a 5 as opposed to a -5. So it's x plus 6, x minus 1. So in this case, again, I get plus minus or minus plus. Okay, so in terms of the patterns that we find when we factorise, if I have plus plus, I get plus plus. So I get plus 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 plus. That's all pluses. Okay. If I have negative plus, this is sort of the one to watch out for. If I have minus plus, then both must be negative. And this is because of two negatives multiplying to make a positive. So this one here is the one to watch out for. If it goes minus plus, think about it being minus minus. If it's minus minus or plus minus, these ones follow kind of the same pattern. You'll just have a plus and a minus. Okay, so just be aware of those patterns before we move forward. Okay, so a few more sort of challenging ones. Here we have x squared plus 5x minus 14. I have x squared minus 17x plus 60. And I have x squared minus 6x minus 55. Now what you can do here, if you want, is you can pause the video. You can have a go at these yourself. But I'm going to crack on with answering them now. So we know that I have plus minus, which means my answer, my pattern, is going to go something like plus minus or minus plus. So I want two numbers which add to make 5 and times to make minus 14. Well, think about my factors of minus 14. I could have 1 and 14. That's not really going to work. I could have 2 and 7. That's pretty much it. So let's have a think about this. One's got to be negative, and we've got to have positive 5. So this 2 and 7 makes sense, and I think the 2 must be negative. So let's see if that works. X minus 2, x plus 7. If I check by expanding this back out, does it work? Yes, it does. Good. Okay, so it's x minus 2, x plus 7. The next one, I have minus plus, so let's think back to what we just did. This means I must have 2 negatives, okay? Minus, minus. Two numbers which add to make 17, times to make 60. Well, thinking about it, 60, let's try 5. 60 divided by 5 is 12. Minus 5 minus 12 gets you to minus 17. Perfect. So it's minus 5 and minus 12. Again, you can quickly expand it. It works. Okay, last one. Minus minus. This means I'm going to be aiming for 1 plus and 1 minus, because they're both negative. So two numbers which times together to make minus 55, add to make minus 6. Okay, well, 55 lends itself to 5 and 11, so let's try that first. And actually, that looks pretty good. It's going to have to be minus 11, because 5 minus 11 is minus 6. So I have x plus 5 and x minus 11. Let's just check it. You can see how long it takes to do this. It takes very, very little time to check your answer, but you know you are absolutely right when you do that. Okay, so that's factorising quadratics in the form x squared plus bx plus c. And this is what I would say is the sort of the easy stuff, really. Okay, but make sure you've got that skill sorted before you move on. Okay, so if I want to factorise quadratics which are more complicated, I'm going to look at quadratics in the form of ax squared plus bx plus c. Now, the reason, and the sole reason these are more complicated, is because of the a. Okay, having a coefficient of x squared makes our life more difficult. But we have a method, in fact we have a couple of methods which are going to help you with this. So I'm going to go through 3 questions and 3 examples to help you. The first one we have is 6x squared minus x minus 2. Okay, so what you can't do now is think, right, well I need to add to make 1 and times to make minus 2. That doesn't make sense. Instead, what you need to do is you need to think, if I times 6 by minus 2, I get minus 12. And minus 12 is an important number here, because what I want to do is I want to find 2 numbers which times to make minus 12, but add to make minus 1. So in a way it's quite similar to what we've been doing before, but we don't use this last number of minus 2, we use this last number multiplied by the first number. So it's minus 12 times to make minus 12, add to make minus 1. Well, we can think about it. We could have, let's try a few. So 2 and 6, 3 and 4, 1 and 12. Okay, so times to make minus 12, 1's got to be negative. I want to find one to the difference of 1. So 2 and 6 are out, 1 and 12 is out, 3 and 4 is what we're looking for. Which one's negative? Well, it must be the minus 4. So now that I've worked this out, I rewrite my expression. I write 6x squared minus 4x plus 3x minus 2. Now the reason I write it like this is because, remember, this is basically what our expansion is. When we've expanded it out, I would have had this to start with, and these two will add together to make minus x. So all I've done is sort of expanded out that minus x into its constituent parts. And by doing this, I can then factorize and group them together in order to factorize my expression. So what I'm going to do is I'm going to group them like this and expand. So if I factorize this first bracket, I get 2x brackets 3x minus 2. I then look at the second bracket and I think, well, actually I can't expand, I can't factorize this bracket, so I'm going to leave it as it is. Now, what I do is I say, well, clearly one of my factors is 3x minus 2. My other factor must be this term here, 2x, and this term here, which is 1. So I get 2x plus 1 and 3x minus 2. I'm going to show you another way of doing this, which is called inspection method. So if I start again with 6, so if I start again with 6x squared minus x minus 2, what I could do is I could simply put it into a box like this, put in the numbers that I know, and then think to myself, well, I could try a few things out. So one thing I could try is I could try my factors of 6. So I could try x squared and 6x. And I could think, right, what are my factors of 2? Well, in here and here must be 2 and 1. So let's look at this. 1 must be negative. Let's say it's this one. So this gives me minus 12x squared. This gives me x squared. Ooh, these two don't add together to make minus x. So I say, okay, that's wrong. Let's try something else. I could say factors of 6. So I could say 2x. Sorry, those should not have been squares before. Apologies. So I could say 2x and 3x, which gives me the 6x squared. I could then say, okay, I've got my minus 2. I could put in 1 here and 2 here. Let's think about this. Okay, so 2 times 2 is going to be 4x. That's going to be 3x. I need these two to add to minus 1. Okay, so I can just put that as negative, which makes that one negative. Therefore, this now works, and it spits out my factors. Okay, so this is called inspection, and it's a bit of a sort of trial and error method, but actually it takes about the same amount of time as the other method, and sometimes you can just see it straight away. So it's not an all-encompassing method, it's not going to solve all your problems, but it is quite a nice way of thinking about it. If you use box method to expand, you can use factorize, you can use it in reverse to factorize it. Okay, let's have a go at another question. Okay, so the second one of these, 3x squared plus 32x plus 45. Okay. So we times 3 by 45, which gives us 135. We then think to ourselves, okay, I want two numbers which times to make 135 and add together to make 32. Okay, could be interesting, but let's start with what we know. So this is divisible by 5, so a factor of 135 is 5. So that's going to be 5 times double this divided by 10, so 27. Let's have a think. We also know that 3 times 45, but they're not going to add up to 32. But hold on, 27 and 5 do add up to 32. Okay, so what we're going to do is we're going to expand our middle term. Our middle term is going to become 27x plus 5x plus 45. By the way, it doesn't actually matter which way round you write these two. If you write 3x squared plus 5x plus 27x plus 45, it doesn't actually matter. You'll always end up with the right answer. So don't feel like you need to make a decision here, which is going to affect your answer. I always think to myself, I usually put the bigger number first. Don't know why, it's just habit, but it doesn't really matter which way around you write them. Factorise these first two. Okay, so 3x outside, x inside, plus 9. And one thing you will get used to is the idea that this bracket here will be the same here. So what I actually could do, bit of a cheat, but what I could do is put x plus 9 here and then work the other way. Well, clearly, I've got to have a 5 outside. If I expand that, 5x plus 45. Perfect. So my factors, 3x plus 5 and x plus 9. Done. If you want to, you can expand this back out in a box just to check, or however you want. 3x and 5, x and 9. I get 3x squared plus 5x plus 27x plus 45. These two add together to make 32. We're happy. Hopefully you're starting to see the idea of working forwards and backwards with expanding, and that we essentially, factorising becomes a bit less sort of magical and a little bit less cryptic when you realise where it's come from. Okay, the third and final one for this type. 4x squared minus 18x plus 20. Okay, now there's two things I could actually do here. I could, if I wanted, I could actually simplify this by dividing it all through by 2. I'm going to leave that to the side for the moment. I could do 2x squared minus 9x plus 10. We'll come back to that. But let's leave it, let's have a go at it as it is for the moment. 4 times 20 is 80. Two numbers which times together to make 80, which both must be negative. Okay, this rule still applies, minus plus, so it's going to be minus 8 and minus 10. Okay, 4x squared, let's expand that middle term. 4x squared minus 8x minus 10x plus 20. Factorise the first two terms. 4x brackets x minus 2 minus 10 brackets x minus 2. Notice how by taking a minus 10 out, this sign has to change to a minus 2, so that when I do minus 10 times minus 2, I get positive 20. So my factors are 4x minus 10 and x minus 2. Okay, now you might be thinking 4x minus 10, I could simplify that. Well, let's go over to this side and think about this question again. I have 2 times 10, which is 20. So I could have 2 times 10, they both have to be negative, that doesn't really work. I could have 4 times 5, that does work. So I can rewrite this one as 2x squared minus 4x minus 5x plus 10. Group and factorize. 2x brackets x minus 2 minus 5 brackets x minus 2. And my factors come out to 2x minus 5 x minus 2. Now look, these are the same. They are exactly the same. If I was to solve this, 4x minus 10 solves to 5 over 2, and so does 2x minus 5. So these are the same. And so this up here is a very helpful step which saves you a bit of work. I think it's fairly obvious that this side on the right hand side was easier to work out than the left. If you can divide all your terms by a number, then do it. It makes your life easier. Okay, these are all factors of 2. Take a factor of 2 outside and you can work it through. In this case, it hasn't made our life an awful lot easier, but in some cases it will do, especially if you're working with really, really big numbers. Now, none of you would do this, 400x squared minus 1800x plus 2000. None of you would do 400 times 2000. Hopefully, you would knock off these zeros to simplify. So why not do it when it's got a factor of 2 in it? Okay, make your life easier. Right, difference of 2 squares, or dots. Now, the difference of 2 squares we've looked at with expanding. We need to be able to factorize these with some confidence, and they're not always as easy as they first look. We need to be really careful. So here's a few examples. 4x squared minus 9, 9x squared minus 16, 16x squared minus 81. Now, I think the best way of doing this type of question, as long as you recognise it is difference of 2 squares, which is the first challenge, is to simply look at the last number and write that in. So square root of 9 is 3, so 3 and 3. We know for difference of 2 squares we must have 2 different signs. For 16, it's going to be 4, so it's going to be plus 4 and minus 4. For 81, it's going to be 9 and 9, plus 9, minus 9. And then we look at the first number. The square root of the first number is 2, so it's going to be 2x plus 3, 2x minus 3. 9x squared is going to become 3x plus 4, 3x minus 4. 16x squared is going to become 4x. So it's 4x plus 9, 4x minus 9. Okay. These aren't too bad, but we might get something like this, x to the power of 4 minus y to the power of 4. Now in this case, you can just think along the same lines. This is going to become x squared plus y squared, x squared minus y squared. Okay, and again, in any case, if you're finding it difficult, write it into a box. Think about what's going to go where. Clearly, these two terms cancel. One's negative, one's positive. Okay, so that's difference of 2 squares, and it's all about recognizing it. Okay, the amount of conversations I have with pupils, or students I should say, when they just haven't recognized it's a difference of 2 squares. Okay, so be really, really, really careful. Okay, the last thing to look at is something that I would call simple cubics. Simple cubics. And the reason I call them simple cubics is because they go in the form of ax cubed plus bx squared plus cx, and there is no number term. You will learn to factorise more complicated cubics, but for the moment we're just looking at them where they all have an x in. And that's a bit of a clue to how we're going to solve them. So here's one for you. We have x cubed plus 9x squared plus 14x. Now, it's a cubic, yes, but crucially, it's got an x in each term. So we're going to factorise an x out to start with. Now, when I factorise out that x, notice what happens. I have a quadratic. Now, this quadratic I can factorise. Two numbers which add to 9 times to make 14. Well, that's going to be 7 and 2. So fully factorised, it's in this form. The factors are x, x plus 7, and x plus 2. Okay, taking an x out means that we have a factor which is x. Okay, I can go through a few more examples of these. Okay, so here we go, x cubed plus 3x squared minus 10x and 6x cubed plus 7x squared minus 5x. Okay, the first step again, take an x out of all of it. We'll do the same on both sides. Now in this case, inside the brackets, I have a fairly straightforward quadratic. Two numbers which add to make 3 and times to make minus 10. Well, one's got to be negative. So we're going to be looking at factors 2 and 5. Minus 2, it must be 2 that's negative. So we have x minus 2, x plus 5. In this case, we have a number before x squared. We have a coefficient, so it's a bit more difficult. Times 6 by 5, we have minus 30. Two numbers which times to make 30, add to make 7, and one of them's negative, so I think 3 and 10 works, make the 3 negative. So we have 6x squared. Let's go for minus 3x plus 10x minus 5. Factorise each bit individually. 3x squared. Let's go for 2x minus 1, that makes sense, yes. Plus 5 brackets 2x minus 1. This becomes, as a double bracket, 3x plus 5, 2x minus 1, and then put the x back on the front. We are factorised. Okay, take the x out to start with, and then it's no more difficult than solving a quadratic. Okay, so the very last two to look at, what if I have x cubed minus 64x, and what if I have 9x cubed minus 16x? Okay, well, these look like difference of two squares because of the numbers, and actually once we take a factor of x out, that's exactly what we're left with. So take an x out, x squared minus 64. Okay, and this one, take an x out again, 9x squared minus 16. Again, x brackets, 3x plus 4, 3x minus 4. Okay, so for the moment, you're not going to have to factorise anything worse than a quadratic, okay, that you can't just take a factor of x out of. So yeah, you could have cubics, but you're going to be able to take a factor of x out and you're going to be able to solve it. Right, that's it for this video. For practice, it is exercise 1B in the Year 1 textbook. Yeah, and have fun.